Right. So we took a look in 7.1 at the sine law, and today we're going to take a look at the cosine law. So the cosine law is not the same as the sine law at all. It's very, very different, but it's similar in that we are using a trig function, right? So the trigonometric functions that we've learned are sine, cosine, and what? What's the other one? Tangent. Very good. So we've learned a sine law, and we're going to learn a cosine law today. There is no tan law that we're going to learn. So the cosine law is a bit to remember, but it is very helpful in certain situations. So I think I should just zoom in here a little bit for you so you can see this a bit better. So the cosine law. All right. If you want to know the side length or an angle in situations where the sine law does not work, then you might want to look at the cosine law. So just as a refresher, the sine law, right, if we have a triangle like this, the key for the sine law is having an angle and its opposite side, a pair, right? We need to have a pair of those. So if we have one pair of those and then one of anything else, we can solve. So let's say we have this angle, but we don't know this side. As long as you have one pair, this one, where this angle is known and this side is known, then you can set up the sine law. But there are situations where you won't have this situation, where you have this angle and opposite side pair. And that's where the cosine law might come in handy. Okay. So let's see. For example, if, well, here's the formula. So I'll just outline this. You see this on your paper there? This is the formula. And it's very, very similar to a formula that you guys know. Can you see in there a formula that you guys already know? That's part of it? Okay, well there's cos in there, yes. What did you say? A squared plus B squared equals C squared. Now they've got it rearranged a little bit here, but yeah, if you just look at this part right here, A squared equals B squared plus C squared, that really is like the Pythagorean theorem, right? It's like two sides. When you add their squares, it's equal to the third side squared. So that's kind of like the Pythagorean theorem. So yes, it's very, very close. The extra part is this little extra part right here. Okay? And so we're going to walk through this. Okay, we're going to walk through this because you can solve for any side if you're given the other two sides and the angle that's opposite of it. Okay, so that's what the angle opposite of this one over here. So let's just say, for example, let's say if you have all three, you have two side lengths. So I have this one. Let's say C equals 8. Okay, and I have A over here, and this one over here. This A equals about let's say 6. Right, and I also have one angle, and I have this angle right here, and let's say this angle is about 30. Okay, 30 degrees. If this were the case, where you have C, you have A, and you have big angle B, you wouldn't be able to use the sine law because you only have one angle. You don't know these other two. So you don't have an angle in its opposite side pair. You see that? So this is a case where it's like you can't use the sine law and you can't use the Pythagorean theorem because it's not a right triangle. Okay? So how do you start to find these other sides and other angles and such? So this would be a case where we would solve for this side. Now, let me show you how we would set this up. This unknown side is going to be the side that's on the one side of the equation all by itself. So I'm going to write this as B squared. Okay? If you're looking for a side like that, you can put it on the left side and square it. We also need to put the lengths of the other two sides right here, the other two sides squared, and we need to add them together. So 8 squared plus 6 squared. Okay. So again, I'm just trying to set this up so that we can look for a side here. Now, we have to put a minus, okay, and that 2 times, notice that this is the 2 times the numbers that we squared here. So 2 times 8 times 6. You see that? You use this number and that number, and they go there and there. And then that is times cosine of the angle, and this angle is the one that's opposite of this unknown side. So this is the side that we can solve for given this information. So that's what it kind of looks like. Now if we were to actually do this one, this is a made up example, if we were actually to do this, you could get your calculator out, and you could have a lot of fun with this. Maybe not fun, but let's figure out what the right side equals. So 8 squared plus 6 squared minus, now I'm going to put all of this inside brackets because they're all this is all multiplied together. This is the same as doing all this, okay? So times 2 times 8 times 6 times cos of 30 and bracket. And well, it looks like I need to do another bracket there, I guess. Okay? So I'm evaluating this right side, and you can do this all at one time if you wish. Just want to make sure I'm on degrees here. Yep, I'm on degrees, so let's find the answer to that. 16.86. Okay, so on this side I've got 16.86. That equals b squared. So in order to get b all by itself, I have to take the square root of both sides. So the square root of that answer is 4.1. Now what you want to do is you want to check real quick to see if that's reasonable, and if this side is 8 and this side is 6, this side really could be 4. That looks pretty reasonable, right? So you've got your side length here of b, and that's using the cosine law. Okay, so the big thing is remembering this formula. So let's see here. Okay, they do an example just like we did. Now remember that this side, okay, that you're trying to find here, if you've got a side and you've got an angle and you've got a side, okay, S-A-S. If you've got side angle side like this, you can always find the third side using the cosine law. And so you'd start off with this a is over here, so that's a squared, all by itself on one side. And then the angle that's opposite, the a, is the cos of a at the end there. Then you do, like Pythagorean theorem, b squared plus c squared. And then you always do the minus 2 times b times c, and then cos of a. So it's always the same way. It's always like that, depending on which side you have out. So it's not always a squared on the end. It could be b squared, it could be c squared. So if it's c squared, let's say, then I would put b squared and I would put a squared here. See that? And then I would do 2 minus 2 times a times b cos of c. So they're always in the same positions. Here's the little c and the big C. Here's a and b, and here's a and b. Okay? That's the format. So let's do an example from scratch, okay? And we'll use the cosine law. So let's do this build your skills question here. Okay, you guys good so far? Any questions? Okay, we're going to go through this again, and we'll show you how to do this. So this one's very much like the first two examples we looked at. Calculate the length of the indicated side, that's r. So guess what? We're going to do r squared. Always have to start off with the side that we don't know. Let's put that on the left side of the equation, squared, all by itself. Then we're going to add this squared plus this squared. Those are the other two sides. So 6.5 squared plus 4.3 squared. Then we're going to subtract what? Subtract 2 times these numbers, right? 6.5 times 4.3. And also times, because it's the cos law, you gotta remember, times cos of, well, it's the side that's, the angle, sorry, that's opposite of this little r, that's 61. Okay? So why don't you guys go ahead and evaluate that on your calculator, just to make sure that you can do that on your calculator. And remember, this is squared, so we're gonna have to take the square root once you get this side all figured out, okay? So you go ahead and take a minute to try that in your own.
I have a question.
Okay, so here's, you should have R of 5.8 kilometers, this one. And if you write all these decimal places, that's okay. In the question, you'll notice there's one decimal place there that the measurements are given, so that means your answer can be to one decimal place, if you're wondering. All right. So that's that's that type of question. Now I believe that there are some other practice questions. So B is similar. Number 2 is also very similar. Notice that we have a side and an angle. So side, angle, side. And they're asked for the length of the pond. So this is just a word problem with the exact same type of calculations. Okay, so these are all the same. And this one too. We've got a side, angle, side. They're just looking for this length right here. So those questions shouldn't be too difficult for you. I am going to go to example 2 here for the next half of this lesson here. So let's take a look at example 2 together, because example 2 is using the cosine law a little different way. So this is where we find what an angle is. Okay. So in example 2, we take the cosine law, which is let's say it's this: a squared equals b squared plus c squared minus 2bc cos a. All right? So that's the cosine law. Now, if we want to solve for an angle, we need to get this all by itself, which can look a little tricky, but let me show you what to do. We need to get a all by itself over here, so let's subtract b squared and let's subtract c squared. So what we have is we have a squared minus b squared minus c squared equals negative 2 times b times c times cos a. Okay, that's the first step. It's because these are gone, and we've brought them over to the other side. Now what we need to do is we need to divide both sides by negative 2bc, because those are multiplied. Negative 2bc. And then we're getting close. So now what we have is we have a squared minus b squared minus c squared over minus 2bc equals cos a. All right, so we're very, very close. And this looks a little different than this. I'll grant you that, but it actually turns out to be the same, because I have little different signs both on the top and the bottom. So this is still good. So once we get this figured out, do you remember how we find the angle inside a trig function? Yes, second function. Good. So then we're going to do second function cos of this right here.
Wouldn't that negative 2 be positive?
Nope. No, it should be. No, that's correct. No, we're not. Okay, so the question is, wouldn't this? Oh my goodness, I can't move this. Wouldn't this negative 2bc be positive? What? Something's happening there. Okay, let's just forget that down there. Okay, that's a good question. Let me just explain that for a second. So we are dividing, because this is negative 2 times b times c times cos a. So we're dividing, we're not subtracting here. Okay? If this was, a minus 2bc, and we had to add it to both sides, this would be positive, but we're dividing, so we have to keep the same sign. So it would be the cos of, just this right here, cos of that equals a. Got it? Okay, so let's just take a look at the rest of the solution. So it should be 31. Let's do a build your skills question to just kind of practice that. And if you want to write down the two kind of versions of the cosine law, you can do that. You can write cos a equals. But I'm going to show you how to do it just from the one memorized version. It'll be really easy. Okay. So with this one, we're given side, side, side. That's another example where we have to use the cosine law. We do not have a sine law situation because I don't have any angles. So we have to use cosine law here. We're going to try and find out what angle Z is. All right. So what we're going to do is we're going to start off with the side that's opposite Z. That's the one that's going to be on the left side of the equation. Remember that? So the side that's opposite of the angle that's in the question, that's the one we start with. So 5.1 squared equals You just keep going with your memorized sine law. 12.3 squared plus 8.2 squared minus 2 times 12.3 times 8.2 times cos of z. Okay, let me know if you're having any problems here so far with this. Okay, if you're with me here so far, let's just start to simplify this. So let's evaluate this into a number. Let's evaluate this into a number, and let's evaluate this into a number, and then we'll just simplify a bit. So what I'm saying is, you don't have to rearrange all these numbers. You can start to kind of figure out what some of them are. So 5.1 squared, that's actually going to be on this side of the equation, 26.01. Okay, and then 12.3 squared is going to be 151.29. You see what I'm doing? 8.2 squared, 67.24. So you can start to kind of do something like this. 2 times 12.3 times 8.2, 201.72. Now this is actually 201.72 times cos of z, so that's all one term there. We've got to remember. Okay, so if you added this all at once, that's great. I didn't. I found them separately. So watch what I'm going to do now. So I'm going to add these two together now. 151.29 plus 67.24. Good idea to make sure you're writing everything out each step so that you don't mess up on any numbers. It's 218.53. Okay. All right, so now we can put a couple steps together if you want, but I'm going to subtract 218.53 from both sides now. And then I'm going to divide both sides by this negative 201.72. Okay? So that you're going to end up with just a cos of z over here on this side. And now I need to evaluate this right here. 26.01 minus 218.53, and then divide that by 201. So here I've combined a couple steps for you in case you want to do something like that. I'm sorry, that's going to be a minus 8.53. And you can hit equals there. So that's negative 192.52, and I'm going to divide that by negative 201.72. So you should get something that's less than 1. 0.95 is perfect. 0.95439. Okay, so this is a lot of writing down, a lot of steps, a lot of numbers. Yeah, you're right. This is going to take some time. If you need extra paper, then certainly you can work on another paper, just attach it. But now what we're going to do, the final step is just do the second function cos of that answer. And just use the entire decimal, give you a real accurate answer. So 17.37 is what I got. Did you guys get that? Or 17.4 degrees for the angle Z. Okay. That's so some of these questions are getting a little bit long now, aren't they? Okay, let me know if you have any questions about that. Did you get that answer? Or?
I got one.
You got one?
Like
where? Over here?
Yeah, I got one. So I just probably add.
Okay, let's double check some things. Okay, so we double checked some things. This is the correct answer right here. You can do it some different ways. You can evaluate, different numbers at different times, but we should get all the same answer. Okay. So, do we need to do another one together? Do you want to do one of these other ones together here? let's see, what do we have before us here? Okay. I tell you what, why don't we do 5 together? Why don't we do 5? I'll just zoom in there a bit. So this is a bit of a word problem, although it's got a diagram, so it's like hardly a word problem, right? Like it's not really a word problem because we're given a nice diagram and all you need to do is use that diagram. So at what angle of elevation is the longer section of this shed roof installed? So that's this angle right here, what we're looking for, right? That angle. So let's see. I have to use, well, do I have to use cosine law or can I use sine law? I don't have any of these angles, do I? But I need kind of all three sides, so how do I know what this side is? Sorry? So here's I see this triangle right here. See that triangle? What's the length from B to E? Yes, it's oddly similar to C and D, yeah. So it's this length. So because we're assuming this shed is like square, right? Like the bottom here should be the same length here. Okay, so now we have a triangle with these three side lengths. That's feet as well. And we're trying to get this angle. Okay. So what that means is this is gonna be cos of I don't know what, right? But let's fill in this whole cosine law formula. So I'm going to start with this side is going to be on the left side all by itself, remember? The side that's opposite of the angle that's either known or unknown, that's what's on the side by itself. So 4.9, don't forget the squared. Here I'm going to put 9.2 squared plus 12.6 squared.
Does it matter which one you put first?
It does not matter which one of these you put first, no.
Okay.
No, because they're adding together, so 1 plus 4 is the same as 4 plus 1, right? So it doesn't matter which one you add first. Yep, good question. So then we're going to go minus 2 times, and again, it doesn't matter which one you write first here either. Okay, and that finishes off our cos law. So let's try and do all of this at one time with our calculator. Okay, can we do that? I think we can. Okay, so let's do a bracket. I'm going to do 4.9 squared minus 9.2 squared minus 12.3 squared. Okay. And I'm going to end bracket there, and I'm going to divide this now by this part here. I need to divide it by this section here. So it's kind of going to be all at once, not technically, but negative 2 times 9.2 times 12.6. Whoa, why did I put 3 up there before? Just noticed that. That should be a 6, right? 6, okay. Just hit the wrong button. Okay, so what do we get there? 0.946299. Okay, I'm going to stop and write some stuff down here now. 0.946299 equals cos of unknown. So you can do all that in one step. If you know what you're doing there, you can save yourself a little bit of time and get this number all in one step by subtracting this, and then dividing by this part. So second function cos of this big long decimal answer, just type in the answer there, equals 18.86. Or it looks like this unknown angle is about 18 point, and we'll round to one decimal place is fine, 18.9. And put our units in there, that's degrees, right? Now, you may find in the answer key or something that you see if you look at the answers, if I give you the answers later, it might say 19 degrees. They might round to the nearest degree.
Okay, because I got
Yeah, they might round to the nearest degree. I don't know if you should get 19.1, but it depends. Try and keep all your decimal places here. Don't round too much here.
I broke it down. I didn't put it all into my calculator.
Okay, make sure you keep all the decimal places as much as you can until the very end.
Okay.
Because yeah, you might, if you get 19.1, you're starting to get a little bit away now from a real accurate answer. So keep 4 or 5 decimal places at least in everything, okay, until the very end. And like I say, if you can, like I did, I just used the answer function, and that copied all of these decimal places. That's the best, if you can do that. Okay? All right, so that's number 5. Yeah, you should be able to do, you should be able to finish all of 1 to 6 now. And yeah, I think what we'll do, I'll save this for tomorrow. Okay, and I'll get you to do 1 to 6, finish all those. You've got some class time now to work on that.